Hello students, welcome back to our channel. So students, we are studying chapter alternating current from class 12th physics. But before proceeding further, we have to understand the concept of phasors, because there are many topics in this chapter that we are going to study after that which cannot be understood without studying phasors. So what are phasors? We know that alternating voltage V is V naught sine omega t, right? And current I is I naught sine omega t. And we know that current and voltage both are scalar quantities, right? Current and voltage both are scalar quantities, they are not vector quantities. But when it comes to alternating current and alternating voltage, we treat them like vectors because they vary sinusoidally. Sinusoidal variation means they depend on sine theta, right? So the value of V changes according to the values of sine theta. You all must have seen the graph of alternating current or alternating voltage, and the graph of alternating current or alternating voltage is drawn like this, right? So this is exactly the same graph as that of sine theta. This value and this value, this is the maximum value. Suppose this is the graph of current, so this is the maximum value of current I naught, and this is the maximum value of current on the other side, that is minus I naught. The only difference is that sine theta goes from it oscillates, sine theta oscillates from -1 to 1 and 1 to -1, and current or voltage oscillates from their in their respective maximum values. Like current oscillates from I naught to I matlab plus I naught to minus I naught, and voltage oscillates from plus V naught to minus V naught, right? So what happens that when you add two currents or two voltages, you first have to see the phase difference between them. You cannot directly add two currents. In case of direct current, we can say that 2 ampere plus 3 ampere is 5 ampere. But in case of alternating current, we cannot say that 2 ampere plus 3 ampere is 5 ampere, because the answer depends on phase difference also. This is exactly like vectors. You cannot directly add two vectors. 2 Newton plus 3 Newton is 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 not equal to 5 Newton. It can be equal to 5 Newton, but it can have some other value also. Like when the angle between 2 and 5 is 0 degree, 2 and 3 Newton is 0 degree, then the answer is going to be 5 Newton. But if the angle between 2 and 3 is something else, then answer cannot be 5 Newton. Same thing happens with alternating current and alternating voltage. If the phase difference between current and voltage is 0 degree, then you can directly add them. But if the phase difference between current and voltage is other than 0 degree, then you have to apply the concept of vectors. For example, if the phase difference between, suppose we have two voltages, V1, let us say we have two voltages V and V dash, right? And the maximum value of V dash is V naught dash sine omega t plus phi. So the phase difference between these two is phi. So when you apply these two voltages across any component, right, when you use these two voltage sources in a circuit, then the net voltage is what? Net voltage V net is, what happens when there are two vectors? Magnitude of first vector is A, magnitude of second vector is B. Then what is the magnitude of their resultant if the angle between them is theta? So the magnitude of their resultant is under root A square plus B square plus 2AB cos theta, and we all know this. So what will be the value of net voltage? That is V square, just like vectors. The only difference is theta in that case is the angle between the vectors, and in this case phi or theta is the phase difference between the voltage or current. So we can conclude that alternating current and alternating voltages can be treated like vector quantities. Not can be. We have no option, right? We have to treat them like vectors, otherwise the answer will be wrong. So the best way to represent alternating current and alternating voltage graphically or with the help of a diagram is by the use of phasors. What are phasors? Phasor is simply a vector which rotates about origin. If we have to define the phasor, then what is a phasor? A phasor is a vector which rotates about origin with angular velocity omega, which rotates about origin with angular velocity omega, right? Okay, what is the meaning of this statement? Suppose this is y-axis and this is x-axis. Now let us say there is a vector, this, which is rotating about the origin. About the origin means the tail of the vector is at the origin and head is somewhere else, right? Like this. So this vector is rotating about the origin like this. One complete rotation. It is continuously rotating about the origin like this. So such type of vector which is rotating with an angular velocity omega about the origin, that vector is called phasor. So if the angular velocity of this vector is omega, then how much angle will it cover in time t? Obviously omega into t. By angular velocity क्या होता है? Angular velocity is omega, that is theta divided by t. So if we have to know the angle theta covered by this vector in time t, then obviously that theta is omega into t. Clear? Okay. So this is a phasor. So how is it related to alternating current and alternating voltage? Alternating voltage V is given by V naught sine omega t. And if this is the angle omega t, now if we draw a perpendicular here, this, then what will be the length of the perpendicular? Obviously, let us say the magnitude of this vector is V naught, right? Let us say the magnitude of this vector is V naught, this V naught, right? So what will be the perpendicular? This y. What will be y? We know that perpendicular by hypotenuse is sine theta. So we can say that y by V naught is sine theta, or we can say y equal to V naught sine theta. Theta means omega t. So this is what? This y is nothing but V naught sine omega t, which is what? Which is the instantaneous value, right? So if this phasor is rotating about the origin, that at any instant the vertical height of its tip from x-axis, that gives the instantaneous value of the voltage at any instant, correct? This is rotating like this, so the vertical height gives the instantaneous value, and the magnitude of this vector is the peak value V naught, and magnitude obviously always remains constant. If this vector is rotating, its magnitude is not going to change, but what will change? This height will change. When it goes to this position, then obviously the height will be more, and when it goes to this position, then obviously the height will be maximum, which is equal to V naught, and that is the point when it acquires its maximum value, right? So this is called phasor. Diagrammatically, it can exactly express everything about the alternating voltage and alternating current, right? For example, in case of resistors, voltage and current are in same phase. So in case of resistors, if we have to draw the phasor diagram, then we can draw it like this. This is the phasor of current, and this is the peak value. This is the peak value, and this one is the instantaneous value of the current, right? And corresponding to this, a graph can be drawn. Just look what I am doing. Okay, now let us draw a graph of current and voltage. Let us draw a graph of current and voltage. Let me erase this first because this graph is going to take a lot of space here. Okay, now if we draw the graph of current and voltage, so the magnitude of current, the magnitude of, let us draw the graph of voltage first, right? So when this, what is the length of this phasor? What is the length of this phasor? This one, yeah, this one. Its peak value, right? Its peak value is this, right? Its peak value is this. So let me draw one more line, this. So this is going to be its peak value, and this line shows the value of voltage at instant t, right? This is the instant t, and this line will show the value of current at instant t, and the peak value of current will be, if we draw the, if we take this here and this one, if we take this here and roughly draw it, so the peak value of current is going to be somewhere around here, right? And just draw a straight line from this also. Okay, so this is going to be the peak value of current. So let us first draw. I am just giving you a relation between how we can draw the graph of alternating current and alternating voltage with the help of phasors, because in NCERT textbooks diagrams like this are given so that you don't get confused. So I am explaining the diagrams, right? So let us say this is, and the same, uh, at the same distance there will be minus V naught also somewhere like around here, roughly, right? Okay. Okay, now let us draw the graph of the voltage, because this graph shows the instantaneous value of current and voltage. So the instantaneous value is changing, right? So if we note the instantaneous value at for every value of t, since the t is increasing, then sin theta will increase, the value will increase. After that the value will decrease. So we will get a graph like this, and obviously we all know that we are going to get a graph like this for alternating current and alternating voltage because they vary sinusoidally. So this point shows this particular point, right? Let us extend this first. Not able to touch it. Yeah. right? So at this point we can say this is the value of voltage, this is the value of voltage, this is going to be the value of voltage V that we have shown in this case, right? So this is the V, this is V, then this will go like this, then this V will increase, this V will attain a maxima here, then again this will decrease, then V will decrease, right? And in same graph, if we draw the graph of alternating current also, then it is going to be like this. This is the peak value, and like this, right? It is going to be like this, and this is going to be the value of current at the same time, that is this value, right? This is the value I, instantaneous value I at this particular instant t, right? So this graph was already known to us. I was explaining phasors. So these phasors are very useful in expressing the value, the nature of alternating current and alternating voltage, and we are going to draw these phasors for different types of alternating current circuits that we are going to discuss after this video. We are going to discuss an alternating current circuit containing R only, C only, L only, series LCR circuit. So in all those cases we will draw the phasor. So it was very important to explain this topic first before we go into that topic. So I'll meet you in those lectures. Till then, all the very best.